Well, greetings and welcome to another week of research methods in higher education. Today I'm going to be providing a small overview about quantitative research methods, and I like to label this Who's Afraid of Statistics? Because by the end of this 2-week series in the course, I hope that you will all feel unafraid of statistics if you are afraid of statistics and excited about the possibilities of understanding how to read quantitative research methods in higher education. So in this podcast, I'm going to preview quantitative research methods, including survey research, which we've been reading about, experimental and quasi-experimental designs, as well as issues of sampling in quantitative research. And then I'm going to provide a brief overview of some basic statistical definitions that are important as we begin to think about how we read statistics in research in higher education. So a few things to keep in mind as we start to talk about quantitative research methods. First of all, quantitative research and statistics is just one language of research. I like to sort of tell students and other people that in research we have different languages, right? So a few weeks ago when we were talking about paradigms, when we were talking about different approaches to research, you can think of these as different languages within the research world. And one of the things that we want to do is be able to speak that language, to be able to understand how to read that language. And this is the way that I really think is helpful to kind of think about research in general, right? That maybe you're not going to be a quantitative researcher, maybe you're not going to be a qualitative researcher or a post-qualitative researcher, but whatever you decide that you want to do, you still need to know the basics of those different traditions, and I think of these as languages, okay? So the other purpose of these units is to help you understand what we should be looking for as we read quantitative research articles, for example. And if you decide that you want to do research, issues that you should be thinking about in designing quantitative research. In a couple weeks, we'll do the same thing for qualitative research and mixed methods research, right? So again, just be thinking as we go through this, not to be paranoid or freaked out that you need to know everything about statistics or everything about all the different types of quantitative research, but to think about this as a language and to be able to determine how you would go and find the appropriate information that you would need in order to answer the questions you might have about particular research that you're reading or research that you want to conduct. So let's talk about survey research first. This is very popular in higher education. Last week we read about a variety of different survey research, longitudinal and national research studies that are going on around the country. And generally, survey research attempts to answer questions about attitudes, behaviors, characteristics, or experiences of student populations or larger populations, right? And we generally have different types of surveys that you might think about. And so I would point you in this case to the NARDI chapter, chapter 4, on different types of surveys. But one thing that's really important to keep in mind is that generally we may think of a survey as either being cross-sectional, so a survey that's given one time to one population, or longitudinal, where we're collecting data over time. So for example, a cross-sectional survey might be a survey instrument that you design on your campus to specifically ask about the attitudes or experiences of students on your particular campus. You might give it one time and you might draw a sample and decide to make inferences about your larger campus population from that one survey. Longitudinal surveys tend to collect data over long periods of time. Still using samples from a larger population, but being able to collect data on similar types of attitudes, behaviors, or characteristics. So for example, the National Survey of Student Engagement, or the Cooperative Institutional Research Program, the SERP survey, those are longitudinal surveys. They've been going on for many, many years, and they happen every year with a different population of students, but they're collecting longitudinal data so that we can compare trends over time. You also want to keep in mind that when you're thinking about survey research, you have different ways of collecting information with survey instruments. You might decide that you want to self-design a survey instrument where you're going to come up with your own questions and your own design for a particular survey. This is often what's done on college campuses when we want to ask about a specific type of issue on our campus. We may decide that we want to use a pre-established research instrument, right? Something that has already been utilized by others. But we may not want to use the whole instrument, so we may decide that we will modify an instrument by picking certain questions from an instrument and certain questions from a different instrument. This is called a modified survey instrument. Or we may decide that we want to use an established survey instrument. For example, if we were going to administer the National Survey for Student Engagement on our campus, we would be utilizing an established survey where students from across different populations are being asked the same types of questions. This is important to keep in mind when you're reading survey research, for example, to see if the author describes that they self-designed a survey, that they modified it, or that they're using an established survey. And this is important because when we get into issues of validity and reliability, you'll want to see if the authors of a research article, for example, are making the correct inferences based on the type of survey instrument that they're using. So that leads us into discussions of validity and reliability. So let's talk a little bit about validity. What does validity mean? This basically means, does the survey measure what it says it's going to measure? And there are different types of validity that we might want to consider when we're reading a research article. Often, when you're reporting on research findings, you're going to talk about some of the validity constructs, right? So one example of this would be content validity. Content validity deals essentially with whether items on our survey are measuring what we say we're measuring. And an example of this would be, let's say that we were conducting a survey about student attitudes towards academic engagement or studying. We would want to look at a survey and see if there are questions that deal specifically with that particular measurement, right? So we might have a survey question on a survey that says something to the effect of, I enjoy studying, right? That would be an attitudinal question that maybe we would rate on a scale of 1 to 5. I don't enjoy studying being 1, I really enjoy studying being 5. And that would give some level of content validity to a construct around student attitudes towards studying. We also might think about predictive validity. So, do certain items on a survey instrument predict other items on the survey instrument? Often what this means is that when you get data back, you're going to look to see if certain items are highly correlated, right? So you might correlate one item with another item. For example, uh, based on the question I just asked, I enjoy studying, right? We might correlate to see if people who answered that question uh, with a 4 or a 5 on a Likert type scale also reported that they spent a lot of time studying. This would be predictive validity. If students who answered a 5 that they enjoyed studying also said that they were studying 15 to 20 hours per week, then we would say that this instrument has some level of predictive validity. And then there's construct validity. So oftentimes what researchers will do is they will ask a series of questions around uh, hoping that there will be some level of construct around those questions. So again, to use the same example, if we're looking at student attitude towards studying, then we might ask a series of questions that we think might garner some insight into student attitude towards studying. And then what we might do when we get all of our surveys back is we might try to use a statistical procedure called factor analysis to see if those items load into a construct that we might label as attitude towards studying. What's important here is that you just know that there are different levels of validity. There's also reliability, and reliability is different than validity, and basically what reliability is there consistency in responses to questions on a survey? Generally, the way that most people will report reliability, either within a construct or within an overall survey, is by using a statistic called the Cronbach's alpha. And generally, what you'll want to see when you're reading a research article is a Cronbach's alpha of 0.70 or higher. That generally means that a survey is very reliable. So you'll want to be looking for those types of things when you're reading research. Something else to consider is how you're going to be administering your actual survey. So there are different ways to administer surveys. By paper, for example, computer-assisted or web surveys are becoming increasingly popular. Telephone surveys are interview-based. And in each of these cases, there are different possibilities and limitations to the type of response rate that you're going to get, as well as the reliability and the generalizability of the survey to a larger population. So I also want to talk a little bit about experimental and quasi-experimental designs. The Cresswell text talks about this. And this is important to think about not necessarily with survey research, but perhaps with research that is trying to figure out, for example, if a specific type of educational intervention is effective for students. So experimental designs are where you have a true control and a true experimental group. So you might have a population of students and you're going to randomly assign them to a control and an experimental group. And this is kind of the gold standard in research. Most medical research, for example, is going to be truly experimental, where there's going to be a population of people and they're going to be randomly assigned to a control group or an experimental group to see, for example, if a new drug actually impacts someone's health, for example. There's also quasi-experimental research, where again you'll have a control and an experimental group, but how people end up in those groups is completely non-random. Most research in higher education is actually quasi-experimental. So for example, let's say we were going to have some sort of educational intervention and we were going to use two different classrooms. We may use one classroom to administer an educational intervention, and in another classroom we may not measure that educational intervention or produce that educational intervention, and then we might see if there are differences in outcomes between the two classes. This is quasi-experimental because students did not have the actual same probability of getting into the experimental or the control group, because they probably selected their class based on time or something of that factor. So this is considered quasi-experimental. It's important to keep in mind when you're reading research that's quantitative whether the research is experimental or quasi-experimental for purposes of generalizability. And this is where we get into issues of sampling. So the key issue in sampling is generalizability. When you're reading research, you want to make sure that you are asking yourself the question of whether the author of the research is making the correct implications about whether their sample matches generalizability. So you want to ask, can I apply the findings from this research study to a larger population, or is this simply informational for me? And here's what I mean by that. Probability sampling means that you have greater generalizability. It's where you're going to be pulling from a full population and being able to make inferences from that population based on a sample. So the very best way to do probability sampling, of course, is simple random sampling, where you have a full population and every single member of that population has an equal chance of being included in the survey research or in the research design in terms of experimental or quasi-experimental design, right? So this is where, for example, you would have a full list of all the students at a university, and you may randomly pull from that list using a number generator or using SPSS, you may randomly pull, and everybody in the population has an equal chance of being included. Stratified random sampling is a little bit different. This is where every member of a particular group has an equal chance of being included. And this often breaks down along demographic lines. So for example, you may decide that you want to make sure that you have 20% of your survey respondents be from each demographic group on your campus. 20% white students, 20% black students, 20% Asian students, 20% Native American. What you would do is make sure that you then pull the full populations for each of those different demographic groups, and then you would do a simple random sample from every one of those demographic groups to make sure that you have 20% from each group. You may have systematic random sampling, where, for example, you're going to pull every fifth person from a list to generate your sample, right? So this is not exactly random, but it's systematic. So you're saying every fifth person on this full population list is going to get this survey, for example. And then you may also consider cluster sampling. So for example, if you're working in a large school district, right, you may decide that you're going to pull all of the schools and put them into a random number generator, and then you're going to pick certain schools from that, and then within that school population, you're going to pick certain people to participate in a survey, for example. This is called cluster sampling. These are all examples of probability sampling, and it's important to keep in mind that with probability sampling, again, you would use probability sampling when you want to pull a sample from a larger population in order to have the best generalizability. We also have non-probability sampling, okay? If a researcher is using non-probability sampling, then there is limited or no generalizability to a larger population. This is really important to keep in mind when you're reading research. If somebody uses one of these types of samples, it's not generalizable to a larger population, okay? It's simply informational. It might inform your practice, but it doesn't necessarily mean that what that researcher found from that particular population is generalizable to a larger population. So for example, we might utilize convenience sampling, right? We may decide that we're going to go and give a survey and we're going to go and give it to all the students in a certain type of class. This is convenience sampling. Whoever's available in the class that day is going to take the survey. It's not random because some people maybe didn't show up for class, some people maybe didn't enroll in a class. It's not a full population sample. So it's convenient for us to collect the data, but it's not necessarily a good representative sample of a larger population. Or for example, if you ask people to volunteer for a survey, this is also a convenient sample, right? Because not everyone is going to have an equal chance of volunteering. Maybe some people can't volunteer because they're working or they're not on campus that day or whatever the case is. So you can't make inferences from that population to a larger population. You may also utilize purposive sampling, right? So you might select a particular group for a particular reason. For example, we might decide that we're going to only survey African American students for some particular reason. In this case, we can't say that the results from this study are representative of a larger population. It's only purposive for the purposes of the research. So the results of that survey can only have limited generalizability, maybe to a particular population on a particular campus. We may use quota sampling. So for example, usually when you're doing research in person, you might decide that you want to survey 50 men and 50 women, right? So often, again, this is a demographic variable. By choosing 50 men and 50 women, you may say the first 50 people, the first 50 men that I come across and the first 50 women that I come across, I'm going to ask this particular set of questions to, right? So I'm meeting a quota. I want 50 men and 50 women. But again, not everybody has an equal chance of being asked, right? It's simply based on the first 50 people that you were able to ask a survey question to. So this is a quota sampling. Again, it's non-probability. Not everyone had an equal chance of being included. And so you want to make sure that you're not generalizing those findings to a larger population. And then a really popular form of sampling is called snowball sampling, where people might pass along a survey instrument to others. So for example, you may decide that you want to uh, do some survey research around a popular one in this regard would be like sexual orientation. So if you wanted to survey GLBT students, right, it's often difficult to find these students because institutions often don't collect that type of information in demographics. So you may go to a GLBT student organization, for example, and you may ask them to complete a survey, and then you may ask those people to pass the information on to other people they know who are also GLBT, right? This is called snowball sampling. Um, this is not generalizable because oftentimes you're trying to collect data from a specific population of people that are difficult to target, and you're asking people to contribute to that population pool by passing the information along. So again, you're getting good information on a specific demographic of people, but it's not necessarily generalizable beyond that particular demographic. When reading your research, it's important, of course, to look at the type of sampling procedure that was used, the type of survey instrumentation, or whether it was experimental or quasi-experimental design, and then to also, for example, if you're looking at survey research, to look at the response rate. The larger a response rate to a survey, the better. The NARDI text says that, a response rate of higher than 70% is usually really good. That's not always realistic. So you want to make sure that you're keeping in mind when you're reading the sample, how large the sample was, and the implications for the study. Generally, research articles will talk about if there's a low response rate, they'll talk about some of the limitations in terms of generalizability based on the fact that there was a low response rate. And finally, in this particular podcast, I want to talk a little bit about statistics, right? I love statistics, it's really fun. And again, I want to emphasize that statistics is a language and that it is critical for you to understand how to read statistics in research. One of the reasons that we're using the Whelan book in this class is because I think that this makes statistics seem less scary for people. And oftentimes people get freaked out about statistics. Our goal in this class is not to teach you how to run statistics, but rather how to read statistics, and that's what we're going to be doing over the next 2 weeks. So Whelan says, for example, that it's, quote, easy to lie with statistics, but it's hard to tell the truth without them, end quote. And also that, quote, statistics rarely offer a single right way of doing anything, end quote. And this is really important to keep in mind as you're reading research articles, right? We often think that statistics are the end-all and be-all of telling us the truth about a matter, but this is not always the case, and I'm going to talk about this a little bit more. So as we begin thinking about statistics, there's 2 different types of statistics that you'll want to be thinking about. One is descriptive statistics. Descriptive statistics tend to classify and summarize numerical data. So we're familiar with this. Percentages, averages, mode, median, these are all types of descriptive statistics. Demographic variables are often talked about descriptively, right? 23% of research respondents were Caucasian. Okay, this is a descriptive statistic. It tells us something about the actual population that we were surveying, or we might say that the average GPA of undergraduates at a specific institution is 3.12, right? This is an average. It tells us something about a population. It's descriptive. We also have inferential statistics. And so inferential statistics are procedures for making generalizations about a population by studying a sample of that population. So a lot of times when you're reading research articles, you're going to read about all these different statistical procedures that people are using to make inferences from a sample to a larger population. So for example, you might read about someone using an analysis of variance, right? Or they may use a multiple regression. There are many, many, many types of inferential statistics. But when you're reading the research, generally when you read this is about utilizing a specific statistical procedure to make inferences from a sample to a larger population. So the question is, does statistics tell the truth? And the answer here is yes and no, okay? One of the things that you want to keep in mind when you're reading any quantitative research and they're reporting on statistics is whether the findings were statistically significant. Statistically significant means it's more likely than not that differences in populations are due not to chance, okay? So if something is statistically significant, it means that it's more likely that there was not a difference between different populations, for example, due purely to chance, okay? It's important to keep in mind also that statistics is always going to be rooted in some level of error. All statistical procedures account for error in their analysis. And all statistical procedures also recognize variance within populations. So while statistics can oftentimes tell us a lot about a sample and a larger population, there's always going to be variance within the population, and all statistical procedures do have some level of error associated with them. So while we may say that something is statistically significant, we have to take that for what it is, which means that there's some level of error involved in that, and there's some level of variance within the larger population. We can still make inferences about a larger population, about whether a particular educational intervention, for example, actually means something, but there's always going to be error and variance. So we have to be able to read statistics and read quantitative research with a really critical eye, and that's what I hope that we'll be doing over the next 2 weeks. So here's a list of references for this particular presentation. And again, I want to just reiterate that as we begin to think about this, there's a lot of issues to think about in terms of sampling, in terms of the types of statistics that we might be using, in terms of how a survey instrument was designed, validity, reliability, a lot of issues. It can feel very overwhelming, but hopefully this little screencast just sort of provided an overview for you of some basic things to think about as we're reading quantitative research. And next week we'll talk a little bit more about how to actually interpret some statistics.